Hello class, let's do the calculation for this last one here. Just to make, so I'm not answering your questions, I'm going to change these numbers up here. So don't copy this, please. So I'm going to be using 100 here. I'm going to be using 240, 160, and 120 here. Instead of the numbers that we have available to us there. The angles, I'll keep them the same, whatever. Okay, so when we draw this shape here, so we have 240 with 0-degree angle, so that's one. So let's do 1, 2, 3, 4, 5, 6 here. Okay, and at 90 degrees we have 160. And at 180 degrees we have 120. Okay, so that's the shape that they would take with the magnitudes, approximate magnitudes here. So if you are adding a force to be in the equilibrium, so you can guess here that it's going to be in the third quadrant because the y component, the x component right here is not enough to cancel this one out, so you're gonna have to add a bit more there, and we don't have anything in the y, negative y, so we need to have at least the y not at least, the y component should equal in magnitude the positive y component that is provided to us in part B of this question. So I would approximate that the answer should be somewhere around here. I would say this is probably the correct answer, but let's see the numbers, why that is the equivalent force. So the easiest thing to do here is to create an x and y component table. Okay, so when we do this, we have the x components and the y components because we have a bunch of them. So for the x component, we have a positive 240. We have a negative, so C is in the negative because 180 degrees, so that's going to be negative 120. In the y components, we have just a positive number in the positive y direction. We have 160 in there. So if you're looking for the resultant force, it's going to be 120. X is going to be in the 120, and the y component of that is going to be 160. That's the resultant, or the force there. It's going to be 120. So technically, if all of these forces added together, they're going to go in the direction. In this direction right here somehow, so 160 and 120, so somewhat this is the resultant force. So it's going to be actually no, not that, it's going to be 3 and 4 up, like this. That's the resultant force. So it's the opposite, the equivalent force is going to be opposite to that. So I think we're on the right track here. But now what are the magnitudes? What are these numbers? So the equivalent, it's opposite to the resultant. So it's negative 120, and that's the x, and the y is going to be negative 160. Very simple. Okay, so if you want to find the magnitude for the equivalent force, so we can say mass, since we're talking about that, of the equivalent force, that's going to be the square root of 120 squared plus the square root of 160, the square of 160, we take the square root of both of these numbers, these squares, square root, we end up with 200. So this magnitude is 200. The angle, now we can find it in many different ways, but we have we know that this side here is 160, and this side here is 120. So if you want to find the tan of, if you want to find this angle right here, so tan inverse of, let's call this theta, is going to be, so theta, that's going to be opposite of the adjacent. So the opposite of this angle is 160. The adjacent is 120. Okay, so tan inverse of that. So second function, tan 160 in brackets divided by 120. That would be 53 degrees. That's but that's not the answer one. So that's from this point, from the negative x direction. So we have to add 180. So the angle that we're looking for right there is 180 plus 53 with 100 and 33 degrees from 0 degrees here. Okay, so that's the direction that we're looking for. Again, I changed the numbers up, so please don't copy these numbers. So 200 and angle to 33 degrees is the angle, the direction. Okay, that's it.